So our case study. So here we are. What we're looking at is a case study where our objectives are, with classification rules, to place traffic to and from the professor's subnet in the professor's forwarding class, to place traffic to and from the student's subnet in the student's forwarding class, provided the traffic does not exceed 100 megabits per second, and place traffic from the students in excess of 100 megabits per second in the best effort forwarding class. And then we have some scheduling rules, which are to give network control traffic high priority and 5% of available bandwidth. Give traffic from professors medium high priority with 45% of the bandwidth. Give traffic from students medium low with 40%, and give best effort traffic low priority and 10% of the bandwidth, and prohibit the use of any extra, in other words, unused bandwidth. So what that means is that even though the other traffic classes are not using all their available bandwidth, we're still not going to let best effort use any of that other unused bandwidth. We're going to limit it down to 10% no matter what. Okay, so here we have our network. We've got router 1 and router 2. So here we are on router 1, looking at the setting up an ingress multi-field classifier. So we're looking at the term from professors. We've got our source subnet there. Then forwarding class professors, which we have set up previously. And then we've got from students, and we've got the student subnet there. Then we're applying our policer to that, which is called student policer. And we're putting the traffic into the forwarding class student. Look at our policer there. We've got a bandwidth limit of 100 meg. We've got a burst size of 625K. And we've got a forwarding class of best effort. So what we're saying is, if it falls outside of those parameters, then it's going to become best effort traffic. And we are applying that filter, the apply cos markings filter, onto GE002. That's R1. R2, we have got a term to professors from the professor's subnet, then a forwarding class professors except, and to students, and we've got a forwarding class students. Oops, sorry, just flipped up the wrong slide there. And we're applying that to GE001. Okay, so let's take a look at the schedulers here. So we're in, so first of all, we've got a couple of forwarding classes. We've got students, we've got professors. We're also going to have best effort. We've got our schedulers there. We have got scheduler, network control. We've got a transmit rate of 5%, buffer size of 5, priority is high. Professors, we've got a transmit rate of 45, buffer size of 45, and priority medium high. So you can see we can set up these parameters of transmit rate, buffer size, and the priority, all which affect exactly how the queue is processed. Look at best effort there. We've got transmit rate %10, and we've got exact. So even if the other bandwidth is free, we're not going to be using it for best effort. Buffer size 10, and priority is low. And we've got our schedulers mapped, our forwarding classes mapped into those particular schedulers there with our scheduler map. So we're mapping a forwarding class to a scheduler. mapping a queue to forwarding class into a scheduler there. So here's our schedulers. You can take a look at different schedulers we have set up there. And let's monitor the results. So show class of service on interface GE003, and we can see that we have got the rewrite, the object, the rewrite, the classifier right there. And if we take a look at the interfaces detail, GE003, we can find the egress queues. We can see we've got queue information on there. And we can also take a look at the packets that are being transmitted in those various queues. Okay, so I thought we might just have a look at that on we'll just take a look at one of our routers that we've got running here, and we'll log into a SRX device that we've got and just get that up on the screen right here. So I'm going to log in to one of our devices. And let's take a look at an interface. So we're going to go show interface GE000. Oops, got the dash 000. But what I need to do to actually see what I'm looking for is I could use the detail command. I'm going to use the extensive command, which is kind of gives you that information, but a little bit extra. So let's just go down here and look at this queue information. Egress queues, we've got 8 supported queues. We're only using 4, so we can actually set up 8 different queues. And in this case, we have got best effort, expedited forwarding, assured forwarding, and network traffic. So that's actually traffic that's going through the network. We can see how much data is going through each of those queues. In this case, on this particular interface, the only thing that it does is attach me to the management network. That's all that's happening right there at the moment. So this is of course the management interface I'm looking at. So that's the only traffic that's there. We've got queue numbers. We've got our mapped forwarding classes mapped to our different queues. So a bit of information there. Lots of other stuff that we're not particularly interested in at this stage. And here is our class of service transmit queue. We can see exactly what percentages and what priorities have been applied to those queues. We've got a best effort queue. It's got 95%. And we have got a network control queue with 5%. We can see the actual bandwidth there in bits per second, priorities, and any limits. So basically, what we've really done here is kind of set up bandwidth usage on this particular one. The priorities are the same. Okay, so that's just information we can pull right out of our interface detail, show interface detail, and see exactly what's going on. The rest of that stuff we're not overly interested in at this point. Okay, so just getting back to our lesson, we looked at the purpose and benefits of class of service. Listed and explained the various components of class of service and implemented and verified the proper operation of class of service. Okay, so let's look at some review questions. How can class of service meet the performance requirements of a network? What do you think? What does it do? What's the basic function of class of service? What does it do, guys? Class of service. What do we actually use it for? Prioritizing different types of traffic. That's basically it. Difference between a multi-field classifier and a behavioral aggregate classifier. When should you use each? So basically, it depends whether we are having a whole of network. Well, we're implementing class of service across our whole network or just within one single router. And we will use both of those when we're doing the whole of network scenario. How are forwarding classes related to queues? Well, as we saw earlier, in fact, when we had a look at our own network here, we might just go and take another look at that. And if we'll go and look at that particular interface, we will see that we have mapped forwarding classes into queues. If we go and take a look at that there's our mapping. So we've got queue numbers and we've got map forwarding classes. So essentially, we map forwarding classes to queues. So that's kind of answers that question. That's the relationship between those two things. And what is the difference between a scheduler and a scheduler map? And essentially, the scheduler is the mechanism we use to service the queue, and the map is the mechanism we use to map the forwarding class to, or map the particular scheduler into that particular queue. Okay, and that is class of service, which is quite important actually. I mean, you imagine a situation where you're the network admin and you say, hey guys, I've got a great idea. We can save a lot of money. Let's implement VoIP across our network. And let's get ourselves out of the telecommunications, high cost trunk calls and all of that. So you go ahead and you implement VoIP and the call quality ends up being rubbish. Well, basically, you know, that's going to be a problem. So one of the things you can do to make sure that the call quality is not rubbish is to implement class of service on your network, prioritize VoIP traffic over data traffic. And if you are sending traffic across a VPN from branch to branch, you would have to, you would be better off with a service provider type VPN. In other words, your service provider is providing you with the VPN, and in that case, they can then provide you with class of service mappings across the link. The downside, okay, this is one of the downsides. One of the downsides of a pure IPsec branch-to-branch gateway VPN is everything that goes out of that router, everything that goes out of that, even across the VPN, is treated as best effort. Absolutely everything, because everything on the internet is best effort. Okay, the internet is basically a best effort system. If we can deliver it, yay, we can deliver it. If we can't, oh well, too bad. That's kind of how the internet works. So this whole mechanism here is really put in place to overcome what is a really inherent design feature of the internet, in that it is essentially best effort. So this is class of service kind of gets around, or helps, or tries at least, to get around that particular limitation, or that particular design issue of Ethernet and TCP/IP generally. Okay, so that really wraps up this term's lectures, and we're going to get busy finishing off our labs. And next term, we're going to be getting into network security, setting up firewalls, setting up VPNs, IPsec VPNs, and a whole bunch of other stuff related to that. Okay, all good. That's it for now.